Problem solving with quadratics and with a discriminant. We're going to start on the side that we're problem solving with quadratics. Okay? The vertical motion formula says if an object is thrown into the air with an initial upward velocity of r meters per second, then its distance d meters above its starting point at time t seconds after it was thrown is approximately d equals rt minus 5t squared. Now I'm going to read that again, but slower this time. Okay? Because I need you to understand what everything means. I don't need to be the Charlie Brown teacher right now. Okay? This is the vertical motion formula. Okay? If an object is thrown into the air, have you ever thrown anything to the air? A basketball? A flag? A football? A what? Oh, okay, softball. I thought you said something else. I was like, we should not talk about that at school. With an initial upward velocity of r meters. Initial upward velocity of r meters per second. Sorry, I should underline that too. R meters per second is the initial upward velocity. So that's r. Then its distance, d meters, above its starting point at time t seconds, God bless you, after it was thrown is this formula. Did I just define everything for you that's in this formula? What's d? Distance measured in meters. What's r? Initial upward velocity measured in meters per second. Okay. What's t? Measured in seconds. What's 5? Does that tell us anything about 5 in here? Oh, so that's just a given. That's given. We don't have to understand where that comes from or anything. That's part of the formula. Got it? And then t? Oh, again, time. We good? So here's the word I circled that I need to make sure we understand before we go on. Okay? I need you to understand that when we're talking about distance, we are not talking about Blake Carr throwing a football 63 yards down the field to Butter, who makes a catch and runs it in for a touchdown. Right? We're not talking about how far it goes. We're talking about how high it goes. Do you understand the difference? Everybody understands the difference. Okay. Number 1, a football is kicked into the air with an initial upward velocity of 25 meters per second. Before we go on and answer any of these questions at all, I need to know what equation we're going to use for number 1. Because this is where I start, but I know more now, don't I? D equals, what do I know? I do. I know r is 25 because it says initial upward velocity of 25 meters per second. Initial upward velocity of 25 meters per second. Does that make sense that r would be 25? 25t minus 5t squared. Before we start, we have to figure out what initial upward velocity we're using for this problem. Is this the same formula we use for every problem on this page? No, we got to figure out what the initial upward velocity is for each problem, right? Okay, now look at part A. Calculate its height after 2 seconds. What goes where? Yeah, that seems logical, right? Put 2 in for t, because t is the time. So 25 times 2 minus 5 times 2 squared. What's 25 times 2? What is 2 squared? 4 times 5? 50 minus 20. Now, 30 answers the equation. What answers the question? Oh, yeah. 30 what? 30 what? just meters, right? Meters per second is a velocity, right? We're just trying to find a distance right now, right? That's just 30 meters. You okay with that? Okay. Calculate its height after 3 seconds. Same thing, right? But this time with a 3. So 25 times 3 minus 5 times 3 squared. 25 times 3? 75. 3 squared? 9 times 5? 75 minus 45? Does that make sense? Here's a guy. He looks like he's jumping off the ground. Give me a break. Here's a football. He kicks it. Isn't that what shape it looks like? How many times could it be 30 meters above the ground? When does this happen? 2 seconds? 3 seconds. Does that make sense? The football is literally not going up to 30 and then straight across and then down again. Frowny face. That doesn't happen, does it? Okay, does everybody understand this? Okay. So is this the right answer? Oh, it's not? It's not the right answer? Oh, 30 meters is the right answer, isn't it? 30 answers the equation. We have to make sure to answer the question, right? Now, somebody was a little smarty pants with me earlier and says, technically that's not a question. Okay, you're right. You know what I'm saying though, right? Jerk. When will it be 20 meters above the ground? $20 meters. 20 meters. What is 20 meters? A distance? Distance d meters above the starting point. Didn't it start on the ground? You kicked it from the ground, right? So where do I put 20? For d, right? Okay. So 20 equals 25t minus 5t squared. Man, wish I knew how to solve quadratics. Oh, we do. Oh, okay. So what should I do to solve this problem? Now, some of you, I can already tell from back here, are having some heart palpitations. Because you know how big you write, and you see how much room you have that goes along with this line, and you see there's also a whole nother question, and I have to figure that out right here. So is it all right if we go to another page and do our work on another page? If what is true, if we keep our work with the worksheet, right? Yeah? So this is C on number 1. So I'm going to say 20 equals 25t minus 5t squared. All right, what am I going to do with this now? What do you want to do? How are we going to solve? So why do you want to subtract 20 again? We want it to equal 0. Now, I'm asking permission. I'm not saying am I able to, because the answer is yes. Okay, I'm asking permission. Can I do 2 steps at once? Because I just subtracted 20 from both sides, right? I don't want to write 25t minus 20 minus 5t squared, because then my next step, what am I going to have to do? Get it in order, right? Rearrange it. So can I go ahead and arrange it now? Okay, so how do you want to write it then? Negative 5t squared plus 25t minus 20. That's much better now, isn't it? Okay, so what do you want to do at this point? We know 5 ways to solve quadratics. Is graphing an option? I guess. Is square roots an option? No, not for this time, right? Because there's a t term in here. We can't do square roots if there's a t term. Okay? Is factoring an option? Is completing square an option? Yes. Is quadratic formula an option? Yes. Okay? What do we want to try to do first? So the quadratic formula is the thing that always works. Can I show you something that might be shorter and quicker? Okay. What if I looked at all three of these numbers and noticed that they all are divisible by 5? What if I actually factor out a negative 5? That's not what I want to do. I want to divide every term by a negative 5 on both sides. What's 0 divided by negative 5? 0. What's negative 5t squared divided by negative 5? T squared. What's 25t divided by negative 5? Negative 5t. And then what's negative 20 divided by negative 5? Well, first of all, that looks a whole lot easier, doesn't it? Okay. Now that my leading coefficient is 1, that brings factoring and completing the square in as close favorites of what we want to do, right? But before we try to complete the square, let's see if it factors. Can you think of two numbers that multiply to be 4 and add to be negative 5? T minus 1, t minus 5. Since it factors, this is way faster than the quadratic formula. Way faster. A lot less ways to mess up. A lot less places to mess up as well. Does that make sense? Okay, what's up? Thank you. That's what I get for trying to talk and write at the same time. But since my job as a teacher, I've got to keep doing that. So thank you for fixing that. Okay. Now what do I do? Remember what it's called? Zero product property. If I multiply two things together and they equal 0, it has to be true about one of them. Or both of them. They equal 0, right? So t minus 1 equals 0, and t minus 4 equals 0. How do I solve for t? Yep. Now I've solved my equation, right? Now answer the question. When will the ball be 20 meters above the ground? Well, what answers did we get? 1 and 4. So 1 second and 4 seconds. Does that make sense in context of the problem? When will the ball be 20 meters above the ground? 1 second. 4 seconds. Yes? Okay. When will the ball hit the ground? So once again, you can tell we're solving for t, right? So what do we need to know in order to be able to solve for t? I need a distance, don't I? When will the ball hit the ground?
0 seconds.
We're not guessing, we're solving. Okay? Because when we guess and just write an answer down and go on, we don't get credit. We show our math to get credit. D means what again? Above the starting point. Where did this start? On the ground? So how far is the ground above the ground? 0. 0 equals 25t minus 5t squared. Isn't that a whole lot easier than the one we just did? All I need to do now is get this in order. And factor. If I take out a negative 5t, what's left? Zero product property says I have to set each one of these equal to 0, right? Negative 5t equals 0. T minus 5 equals 0. What's t equal? 0 and 5. I didn't say you were wrong when you guessed, did I? I just said we have to show our work to get credit, right? But now answer the question. When will the ball hit the ground? Why only 5 seconds? This is where it starts, right? This is where it finishes. That's what we care about right now, right? It's just a matter of knowing what the question is asking. Going back and reading the question. Got it? Any questions about that one? Okay. Number 2. Suppose you throw a rock into the air from the top of a cliff. For the record, if you're going to do that, I need you to be careful that nobody's below you. Okay? And I also need you to be careful not to get too close to the edge of the cliff. Well, I didn't mean to make you so giant. That's really giant. Okay, pretend that's water then. Sorry, I should have made a beach. It is water, right? What's wrong with my drawing now?
No, I'll just call it a reservoir.
Reservoir. I'm proud of you for knowing that word. Okay. So what do we know about this? So we're throwing from one level and ending up somewhere lower than that, right? Look at the information we're told in the first sentence. The initial upward velocity. So what's my equation that I'm going to use for this problem? 15t minus 5t squared. Remember that the initial upward velocity is r. Okay? How high will the rock be above the cliff after 2 seconds? How do you think we ought to do that? Replace the t with 2. So 15 times 2 minus 5 times 2 squared. 15 times 2? 30. 2 squared? 4 times 5. 30 minus 20. 10 is the answer? Oh, 10 meters. Okay. Where will it be after 4 seconds? Perfect. So 15 times 4 minus 5 times 4 squared. So 15 times 4, 60. 4 squared? 16 times 5, 80. 60 minus 80. What? Where will it be after 4 seconds? So now we have to argue, right? And I don't know how I feel about this table. Maybe if I just stay by the barrier. No, I'm just going to stay here. Is that okay? On the chair? I'm on the chair. I was going to stand up here, right here. I'm just afraid my cord is not going to go, okay? Where's my pen in relation to my feet? Below. How would I measure that? So we had this question already, right? We had this discussion already. And I said to you, can we have negative distance? And I said no. And you agreed with me, right? But how would I measure the distance between my feet and the pen? So what distance is that? From my feet to the pen is 20 meters? Like a foot and a half, right? Okay, let's talk about my pen. And we're talking about my feet and the pen. It's okay. It's okay. Like a foot and a half, Are you okay with that? So we would say that the pen is related to my feet how? 1.5 feet below. But if I was doing some math, like an equation, what kind of answer would I get for my distance? I would get a negative, right? I would get a negative number if I'm measuring where the pen is in relation to my feet. So, can you have negative distance? No, you can't. Can you get an answer in an equation that's negative when you are solving for distance? Yes. Okay? It has to make sense in the problem. It can't always work, right? It has to make sense in the problem. But if I get an answer that's negative when I'm trying to solve for distance, I have to look at the problem and say, does this make sense in the context of this problem? And you guys have already said, yes, right? Yes, it absolutely does make sense in the context of this problem, because in the context of this problem, I'm throwing a rock off a cliff, being careful that there's no one below me, right? I'm throwing a rock off a cliff, so what's happening? So for my answer, I got negative 20, right? For the answer of my equation, right? What's the answer to the question? 20 meters below. This is not the answer to the question. This is the answer to the question. If you just write negative 20 meters, I know that you haven't taken any thought or time to think about this. Okay? Are there any questions about that? When will it again be at the same level that you threw it? Did you throw it from the ground this time? No, where did you throw it from? Like where you naturally throw a ball, right? But D is where? Above its starting point. Well, where did it start? At 0. This is my starting point. If it gets back to my starting point, isn't the distance above my starting point 0? Yes. 0 equals 15t minus 5t squared. How am I going to solve that? Oh, rearrange it? Okay. 0 equals negative 5t squared plus 15t. So just factor like it up here on this one. If I take out a negative 5t, what's left? T minus 3, right? Okay. So negative 5t equals 0, and t minus 3 equals 0. So t equals 0, and t equals 3. Now answer the question. When will it again be at the same level that you threw it? 3 seconds. Where does this answer come from? That's the start. Okay? 3 seconds. When will it hit the water 50 meters below where you threw it? What's my distance? Absolutely, negative 50. Now we know there's no negative distance, but when I'm talking about 50 meters below, what number do I have to put into the equation for that? Negative 50, right? 15t minus 5t squared. So what do you want to do to solve this one? So yeah, for sure add 50 to both sides first, right? Can we arrange at the same time? Negative 5t squared plus 15t plus 50. You want to go straight to the quadratic formula this time, or you want to try to factor? Okay, so if we divide everything by negative 5 again, for the record, is it always going to work to divide by negative 5? No, it only works if everything is divisible by 5, right? And why are we dividing by negative again? That gives us an a value that is positive, right? So t squared minus 3t minus 10. Do you know two numbers that multiply to be negative 10 and add to be negative 3? What do I do with each one of those factors? Set them equal to 0. Good. T plus 2 equals 0. So what does t equal? 5 and negative 2. Is everybody okay with me skipping that step? If not, I'll do it. Do you see what step I skipped? This one. Add 5, add 5. That's the step I skipped. Are you okay with that? Now, please answer the question. When will it hit the water 5 meters below where you threw it? Well, what answers did I get? 5 and negative 2. What's the answer? 5 seconds. What does this answer mean? Well, guys, here's what I want you to think about. Isn't this a whole parabola? I mean, this is the part that relates to our problem, right? But isn't this a whole parabola? Guess what this is? Negative 2, right? If we had our y-axis here and our x-axis here, it would intersect over here at negative 2. Everybody understand that? See where the answer came from? No, 2 seconds before I started, I was not standing inside the cliff, right? This is 0, so that's my y-axis right here. And if I continue the parabola over here, this would cross at negative 2. Does that make sense? Any questions? So go and turn that worksheet over, please. No, what I mean is look at the other worksheet. Sorry. Remember, it's not two-sided? That's what I was thinking in my head. Okay? Now notice what the title of this says. Problem solving with a discriminant. What is the discriminant? See, that's what you get for starting to say 4 when I started to write a 2. I'm not going to blame you because it was my own fault. b squared minus 4ac is the discriminant, right? A target plane flies at 2100 meters. An anti-aircraft gun fires a projectile with an initial upward velocity of 200 meters per second. Will the projectile ever reach the altitude of the target plane? Please understand, I'm not asking, will the missile hit the target plane? Because there's a whole lot of other things that have to come into play, right? I'm just saying, will it reach the altitude? So here's what I want you to think about. We got a plane who's flying at this altitude, right? Here's the ground, and here's, I don't know how to draw guns. Pretend that's a gun, okay? Or, yeah, a gun. I'm sorry I said gun at school. I was just reading the word. Okay? What are the possibilities? It shoots it, and that's a possibility, right? It could get as high as the altitude of the plane 2 different times, right? What's going to be true about the discriminant that time? It's positive. Because a positive discriminant is going to give us 2 answers, right? What's another option? One time. What's the discriminant this time? 0, right? If I take the square root of 0, I get 1 answer, because square root of 0 is just 0, right? Or what's the discriminant this time? Negative. So let's see what happens here. Okay, let's use the information they gave us and see what happens. Well, what do we know? What's this? So that's D, so 2100 equals, do I know? Oh, okay, R is 200, T minus 5T squared. So I want to get this in order, right? So let's subtract 2100 and get it in order at the same time. 0 equals negative 5t squared plus 200t minus 2100. Now at this point we could do a whole lot of simplifying and whatever, but all I'm after is b squared minus 4ac. Do I have to do any of that in my head? Or can I let the calculator do all of it? So I'm not worried about how big the numbers are, right? B squared, 200 squared, minus 4 times A times C. $200 squared is 40,000. 4 times 5 times 2100. Do you know that off the top of your head? Oh, 42,000. What is 40,000 minus 42,000? And the most important word in that answer was what? Negative. Will the projectile ever reach the altitude? No. This is the answer. This is the work. Does that make sense? A flea on the floor wishes to jump on a dog's back, 0.9 meters above. The flea can jump with an initial upward velocity of 4.3 meters per second. Can the flea jump as high as the dog's back? What do we know? 0.9 equals 4.3t minus 5t squared. So if I subtract 0.9 from both sides and take the time right now to get it in order, our exponents in descending order, fill in the discriminant. B squared, so 4.3 squared, minus 4 times negative 5 times negative 0.9. 4.3 squared is 18.49. 4 times negative 5 times negative 0.9 is 18. It's 18.49 minus 18.49. Will the flea jump as high as the dog's back? Yes, and how do you know that? That number is positive. This is the answer. This is the proof. Any questions? So what I need you to do is finish both sides. Okay? 3, 4, 5, and 6 on this page. 3 and 4 on this page. Okay?